When first learning to multiply fractions, we usually rely on visual grids to see the logic. But to find a faster way, we have to look back to 628 CE, where the Indian mathematician Brahmagupta was recording a fundamental shortcut. These manuscripts represent the medium Brahmagupta used to document his work. Carved into the leaves are the Sanskrit verses that establish the fraction rules we still teach in schools across the world today. To multiply fractions, multiply the numerators across the top and the denominators across the bottom. It works for whole numbers too. To multiply 3 by 3/4, place the 3 over a 1 and multiply straight across to get 9/4. This straight-across logic is simple, but it creates a computational bottleneck as soon as the numbers get larger. While Brahmagupta's baseline rule is universally true, attempting to multiply massive fractions without an optimization strategy makes the process much more difficult to manage. Ancient Jain scholars addressed this bottleneck using a technique called Apavartana. This method involves canceling out common factors to reduce the fractions before you even start the multiplication. Take a look at this equation. Multiplying 14/15 by 25/42 using the standard rule would result in some very large numbers. We can use Apavartana to simplify this first. 14 and 42 are both divisible by 14, so we can cross them out and replace them with a 1 and a 3. We do the same for 25 and 15, which are both divisible by 5. Now they become a 5 and a 3. Now the multiplication is much simpler. 1 times 5 is 5, and 3 times 3 is 9, giving us the final product of 5/9. By systematically removing common factors at the start, Apavartana turns a heavy calculation into much more manageable arithmetic. With these tools, we can test a common assumption, the idea that multiplication always results in a larger number. This is true for whole numbers, like 3 times 5 equaling 15. But look at what happens when we multiply two proper fractions, like 3/4 and 2/5. The product is 6/20. To see the difference, we can convert everything to a common denominator of 20. 3/4 becomes 15/20, and 2/5 becomes 8/20. The product, 6/20, is smaller than both of the numbers we started with. These three rules help predict the outcome. When both fractions are less than 1, the product is smaller. If both are greater than 1, it gets larger. If you have one of each, the product falls somewhere in between. Fractions function as scaling factors. Multiplying a value by a proper fraction essentially shrinks it. In 1150 CE, the mathematician Bhāskarāchārya used these concepts to pose a famous riddle in his text, the Līlāvatī. He described a miser who offered a beggar a very specific, tiny fraction of a coin. The coin in question was a silver drachma. To solve the riddle, we have to calculate the exact size of the miser's donation. The miser's offer was a chain of fractions, 1/2, of 2/3, of 3/4, of 1/5, of 1/16, of 1/4 of that single coin. If we use Brahmagupta's rule to multiply straight across, we end up with a very large fraction, 6 over 7,680. Applying Apavartana allows us to quickly reduce this. Both numbers are divisible by 6. which leaves us with exactly 1/1280th of a drama. Here is the punchline. Historically, one drama was worth exactly 1,280 cowrie shells. The miser's complex donation was worth exactly one single shell. Ancient mathematicians didn't just use these rules for astronomy. They used their understanding of magnitude and simplification to embed sophisticated jokes directly into their math problems. You now have access to the full toolkit: Brahmagupta's baseline rule, the optimization of Apavartana, and magnitude forecasting. Here is your final challenge. Look at this problem on the board. 12/7 multiplied by 24/5. Try using Apavartana to simplify the fractions first. Once you have the answer, use the magnitude rules to determine if the product is greater or less than 12/7. Go ahead and post your results down in the comments. By applying these ancient Indian workflows, you can approach even complex textbook problems with a clear, systematic strategy.